Hi, my name is Evan Breyer, and here's the problem we're trying to solve. Our web app was made to allow for the easy searching of Mark 21 data. As it is now, you have to write scripts for every search you want to make. While it's easy for a programmer to write the SQL scripts for this, it's not as easy for people who aren't from a computer science background. Mark 21 data is usually used for bibliographic reasons. Because of this, the primary users of this data are historians, not programmers. Having an easy, user-friendly tool to allow for advanced searches to be done would allow for many more people to perform searches. In particular, our client has a dataset of about 6 million book bibliographic data entries. As the data was provided to him, it was an XML file, which is very bad for searching. A historian might not know to make this dataset SQL to make it easily searchable. The goal of our web app is to make any historian or person who wants to investigate these Mark 21 records able to search through it with advanced queries without having to know any programming. Mark 21 is a very specialized format of data that has a lot of parameters. Because so much information has to be stored in them, it's not a very user-friendly way to store the data. Not only does someone who's trying to search this database need to know how to transfer it to SQL, they also need to know which fields to import because not all of them will be relevant. By using information provided to us by our client, we were able to tell which fields are the most important. By doing all of this and making it a generic web app, we can allow anyone who wants to search through it able to. We also designed the website in a way so that it can be easily expanded no matter how much new data is given to us. This gives it functionality beyond just our client because many people have a problem with trying to search through Mark 21 data. By using information provided to us by our client, we were able to tell which fields are the most important. By isolating these fields, we can make it much simpler for the average user to search through this data for what they want. On top of that, we can also look at the kind of searches our client has done before to know which other fields are useful to limit by. With this information, we're able to create an advanced search page with all of the options that someone looking through this data may want to use. And now I'll pass it over to Casey to explain the technologies that we used.
Hi, my name is Casey Blue, and I worked as a front-end developer for this project. These are the technologies we used for the precarious ceiling search system. React, a JavaScript library for building user interfaces. We use this to build the front-end user interface of the web application, and Axios was used to route between front-end and back-end in between the pages. If we were to build this again, we'd use Angular instead of React due to less restrictions within the functional components. Along with React, we used Node.js, an asynchronous event-driven JavaScript runtime framework used to build scalable network applications. The Node package manager was used to install all required dependencies within the web application and keep them up to date. Node.js is quite frequently used along with React. Express, an open-source web application framework for Node.js, used to deliver requests from front-end to back-end frameworks. Builds SQL queries and pulls information from the MySQL database. MySQL, an open-source database management system. This hosts the database in which we store a small cut of the book data that was provided to us by OCLC through Colin Weiler. Plotly, a graphical open-source library. What this is an interactive graphing library with over 40 chart types, including 3D, statistical, and SVG maps. It can be used in other programming languages such as Python, MATLAB, R, JavaScript, Perl, Dash, and many more. Used to show graphical response to user searches and queries. This works well with React state management. Other benefits of the Plotly graphing system is it's easy to save PNGs, zoom in and out, reset frameworks, and many other things. The specifics for the advanced search functions. Any searches any selected tags of strings put into this field using OR algorithms. Separates strings with commas. Exact searches for exact phrases put into this field using AND. Separate strings with commas. None. Exclude results within the selected tags and the strings in this field. Separate these strings with commas also. Tags. Select which tags you are searching through for in the database. Example, author. Year range. Select the year range in which to get the results from. A valid range is 1500 to 1800 given the time period that this database is within. Language. Select which language of books to search through. Uses the Mark 21 language codes found at this website. For example, use ENG for English. Region. Select which regions for books to search through. Uses the Mark 21 region codes found at this website. For example, use CR for Costa Rica. Now I'll be handing it off to show how this application really works.
Hello, my name is Tyron Schultz, and I will be showing some of the basic functions of the Precarious Search System. Starting on our homepage, we have the 3 fields for our basic search. Starting at the top, we have our graph type. You can select from bar graphs, pie charts, and line graphs. Then we have our tags that you can search through: title, author, and publisher. Then you have your search field that you can type in. We will be choosing bar graph and title. And before moving forward, I want to show that the search button doesn't actually work until you select all the required fields. We will be typing in Bible. That seems to be a pretty popular book. So we search, and you can see things published throughout each decade through our graph over time. At the top left, you can see the current search, which is what is currently being displayed in the graph. And under it, you can make a new search. Let's go with pie chart and author. And let's search for James. Now you can see in our search output here that the data is displayed in a different way, showing the percentages of different things over each of the decades that our search system goes for. And at the top left of our screen, you can go to our homepage, and then you can go to our advanced search screen or sign in. I will now be turning it over to Rebecca Sword, who will show some of the more advanced aspects of our search system.
Hello, I'm Rebecca Sword, and I'll be running through the rest of our functionality for this demo. First and foremost, I'm going to want to sign in. Now, you'll notice there's no create account option, and that is because we have kind of a sensitive data set here, and our client only wants certain people to be able to save searches and really access it. So our client will have certain credentials set up to give out to these certain people. For our purposes, we're going to use our testing credentials we've made. Oh, well, that demonstrates that you could fail to log in. There we are. Now you'll notice there's a new button here on the home page, which allows for one to save a search. So I'll go ahead and make a quick search to save. Let's say pie chart of authors named Jacob. And you'll see that has the same requirements as a normal search button. There's also this ability to set a name for a search you're saving. That's more for user benefit, but it's not required, so I'll save this one without a name. And then, since I have that search saved, if we go in the searches page, you'll see that that is there now. There's also these 2 searches that were already here. Now, if I click this, it'll run that search. I can go back, I can click this advanced search here, and it'll run that advanced search. Any of these searches you click, it will run. Now, let's say I don't want that search, I can delete it, and then it's gone from the list. Moving on to the advanced search. You can access the advanced search here, and it also has required fields and buttons disabled when the required fields aren't put in, but it works a little bit differently where you only need one of these 2 asterisk fields filled in. So let's say I want a line graph of titles that have to include James. And then I could save that search, say James Advanced, and I could also just run that search here. So this will show the information of the current search, just like for a basic search. Everything here works the same as a basic search. You could also access the advanced search with this link. And that search I created should be right here, James Advanced. You'll see exactly what you filled in here, as opposed to where the results page shows only the things that were fully filled in. And here it will show that I didn't fill in anything for any words or for excluding. And it'll show which of these tags I'm querying. So if I'm querying title, it'll be marked true, and the others I'm not querying, so they're marked false. I can click this, I can run that, and then I could go back to the advanced search here. Let's say I want to search pie. I want to have the possibility of including the word the. I definitely want Bible. I definitely don't want pie. And let's say I want to search both the author, the title, and publisher. Let's say I want to search from 2000 or 1000 to 2000. And because we're using Mark 21, this would be ENG for English, and then a region code example would be ENK. This would be common knowledge to our clients and the prospective users for this. And then we can run that search. And that'll show pie chart, any, the, and all of these terms here. I could also log out, go back to the home page, and then it's back to the beginning. Thank you for your time.